Hello everyone, so my name is Nael. I am a student here at NYU Tandon School of Engineering, and today I'm going to show you what my summer research is about, and I'm going to try to explain you my project and what it's about. Okay, so the main thing about my experiment is about pesticide. So here I have one pesticide. We all know like it can be very useful for food supply but also dangerous. So the main part of the experiment is try to understand pesticide treatment. So there is already natural treatment that exists as photo direction, but we want to introduce a new emerging system, which is plasma. And plasma is created by, is not natural. We made the plasma system. So we try to treat the pesticide with the plasma, try to understand what is about, because there is a lot of lack of understanding with plasma and pesticide. Also, an important thing about my research is we're trying to develop a model, which is right now show up on your screen. So this model is using different reactive species. It's different for the pesticide, like not every pesticide have the same reactive species. So for this model, it's this pesticide that is about. To quantify the different species, we're using probe. Probe molecule is just a molecule that we're using just to find the different species. It's not very complicated, but we are using all that in the plasma system. So we're degrading pesticide with plasma system, and we're also degrading probe. So with this degradation, we can then calculate the model, and then we can compare the model against the actual degradation via plasma with the pesticide. So the best way to understand what I'm doing is about to show you a demonstration. So here's the plasma system. So the plasma system is made of a positive and a negative polarities. So it's a circuit with an electrical field, and the electrical field is gonna to react with a gas, which is coming back that way, and then it's gonna to touch the liquid, which is inside. So right now it's just water, but when you're using pesticide and probe, we putting this inside of the liquid, and then we're gonna to analyze the result. So here I'm gonna to show you an example. So here's the plasma. So it's reacting with the gas and it's heating the liquid. So we usually wait about 0 to 5 minutes, and we're taking time points between every minute. So what is interesting with plasma is also we can change the parameters. So we can switch between positive and negative polarities. We can also change the current from 1 to 5 about. We can also change the gas. But for us, we're using argon gas because it's better for the data. It's a very simple gas when it's reacting with plasma. So when I'm done with my experiment to collect my time points, I'm just putting this back there, taking my pipette. I'm making the solution homogeneous. So those pipette is collecting microliters, so it's a very, very small volume. I'm collecting about 150, putting inside of my file. Then those files are gonna to be analyzed with a HPLC machine. It's just a machine that's gonna to analyze the concentration of each file, and then with different time points, we can create a graph and other different tools in Excel, which will be there for our results. So by following the procedure, here is our main result for two pesticides, tiobetcam and difenoconazole. So our first observation is that the degradation for both pesticides is linear. We run multiple tries for all of them for both polarities. We can also observe that it degrades twice as fast for positive than negative. So here's our model for tiobetcam. So we can see it's a good flux approximation between the calculated and the observed, but there's a gap between them, same as negative polarities, which the gap is even bigger. So this gap can explain as a model being simple. It's not a complex model, but we can see the different reactive species for this pesticide. We also have the model for the second pesticide, difenoconazole, with still a gap between the observed and the calculated. So how can we fill the gap? So we can maybe we're missing maybe something to the model. It's a simple model, it's not a complex one. We can maybe use different probes that are gonna react differently with the plasma system. We can also maybe play with the parameter as current, gas, but the goal is to develop a good model, a complex model that's gonna to define the baseline of plasma treatment for pesticide.